Hello everyone, Jordan Gilbert back here with my Lab 3 demo where we're going to be measuring the speed of a propeller using a simple IR LED with a photodiode. Let's get into it. So hardware block diagram. At the top here is the UART stuff that we normally have for printing out stuff over the serial port. Timer 0 I use as a basically a 1 millisecond timer just running indefinitely to keep track of how many milliseconds have passed for calculations. This line here in the middle is the detection. So we got the IR LED. I used a 3-blade propeller that sits in between that and the photodiode, which is pulled up with a 10k ohm resistor to 5 volts. That goes into the D2 port on the Arduino, and then we use interrupt 0 with falling edge trigger to capture each individual blade. This whole bottom part here is just a simple motor driver circuit that I used. 10k ohm potentiometer to change the speed, and then PWM through a simple little motor driver circuit to drive the little DC motor. Software is pretty simple. So 2 interrupts, timer 0 to generate the 1 millisecond tick, just basically increments uptime milliseconds. And then the other interrupt is interrupt 0, which is doing the edge detection, and that increments this pulse count. So in the main loop, we initialize all of our peripherals, and then we go through this bottom loop here where we read the potentiometer, set the motor speed, and then check if it's time to do another conversion, which I chose 1 second. So every 1 second I'll do a conversion. So I'll go up here and I'll basically take a snapshot. So I did some atomic operations to ensure the data doesn't get messed up. So basically I just copy pulse count into a new variable and then reset it, and that's done inside of an atomic scope within the Arduino library. And then that copied value is used to compute the RPMs here. So basically the number of pulses times 60,000, which is the number of milliseconds in a minute, and then that's divided by 3,000. So the 3 is because there's 3 blades in my propeller, and 1,000 for 1,000 milliseconds in a second. And then I print out the values to the serial port and repeat. So let's give a quick demo. All right. I'm going to connect my TerraTerm session real quick. Should start printing. I'm going to reset it. Okay. So timer milliseconds, RPM, starts printing. Over here on the right is the motor. The IR LED is all the way to the right. You can't really see it. And then the photodiode's like under the motor here. And then everything to the left of that is the motor driver circuitry. So if I turn this potentiometer, the motor will start spinning. You might hear a slight hum. You can see the values increasing on the printout there, maxing out around 17,000, which is probably a bit fast. I'm not sure it's actually spinning that fast, but that's as good as I could get it. I did some debouncing on the interrupts because it seemed like they were triggering way more often than they should be. But yeah, you can just play with this and turn it up, turn it down. Seems to work pretty good. I'll give a quick demo of a Python program I wrote too. Give me 1 second. I'll be right back and let me get it set up. Okay, back here, I got it set up here down in the bottom left. This is basically a live view. Used a Python script to connect to the UART, and yeah, it'll give you like a live graph. So if you need to increase this enough to get it to spin in, and there we go. Every 1 second, you get it's basically just capturing the data from the COM port and printing it out live. And then anytime I press the reset button, it'll actually save that as a PNG and then start a new one for you. All right, yeah, that's pretty much it. Thanks for watching.